Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at rationalizing the denominator. We're looking at expressions like this, 5 over root 3. Its denominator, the bottom of the fraction, is root 3. That is irrational. So we're going to find a number that equals the same thing. It has the same value, but it has a rational denominator. So what we're going to do is we're going to times top and bottom of this fraction. We want to times this bottom by something that makes this rational. Well, if you times root 3 by itself, it becomes rational because root 3 times root 3 is just 3. But I can't just times the bottom by root 3 without changing the value of this expression. What I need to do is times the top by root 3 as well. So I get 5 root 3 on 3. This number here and this number here, they are both equal. They have the same value, but this has a rational denominator. It just turns out that numbers with a rational denominator tend to be easier to work with. All right, let's look now at a more complicated example. So let's say we have something like this and we want to rationalize the denominator. See, 4 minus root 3 is an irrational number. We need to times this by something in order to make it rational. So what can we do? Well, when you have multiple terms, you multiply top and bottom by the conjugate of the denominator. What does that mean? The conjugate of an expression like this has the same numbers, so 4 and root 3, but it has a different sign between them. The reason this will work is when you multiply this and this together, you can invoke the difference of two squares. So really when we're doing this, we're multiplying them as if they had brackets around. When you multiply this by this, we use the difference of two squares. So we go 4 squared. Root 3 squared is just 3, and then we stick a minus between them. So again, I can't just times the bottom by 4 plus root 3. That would change the value of the fraction. So what you do to the bottom, you must do to the top. I must also times the top by 4 plus root 3. So when you're doing this, it's as though there are brackets around. It's just mathematicians are a bit lazy. So what we're going to do is we're going to use FOIL on the top. So 7 times 4 gives 28, that's the F. Then I go 7 times root 3, 4 times root 2, and root 2 times root 3. So that's just root 6. Okay, so when I do that, I end up on top with 28 plus 7 root 3 plus 4 root 2 plus root 6. On the bottom, I have 13. So you have to look at whether you can simplify this further. We can't here because there's no common factors on the top and the bottom. Just be careful when you have something on the top and the bottom. You couldn't cancel out just one of the things on top. You can only cancel out here if the bottom and everything on the top share a common factor. But this is our final answer that can't be simplified. This and this have the same value, just this one has a rational denominator. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.